Hey everyone. So as engineers, we live and breathe complex systems. We know how to design them, build them, debug them. But what about the process of actually managing the build itself? Today, we're going to deconstruct project management by mapping it onto something we all understand perfectly, the architecture of an electronic system. So, let's fire up the workbench and get into it.
I mean, this is the fundamental question, isn't it? You've got this brilliant design on the board, but taking it from concept to a real working product, that involves so many moving parts, different teams, and let's face it, never enough resources. Just one wrong signal, one glitch in the timing, and the whole thing can crash. Well, project management, that's the control system that's designed to prevent that chaos.
So where do we even begin? Well, you know just as well as I do that every great build, every solid piece of hardware starts with a blueprint, a master schematic, right? The one that defines every single connection, every component, every function. In the world of project management, that master plan has a name, the Project Management Body of Knowledge, or PMBOK for short.
Okay, so what are we really talking about here? Let's get the formal textbook definition out of the way. Project management is the application of knowledge, skills, tools, and techniques to meet project requirements. But here's how you should really think about it. It's not administrative paperwork. It's an engineering discipline in its own right, one that's completely focused on applying a specific set of tools to make sure a system meets its target specs. Period. And this is the most crucial takeaway. Please, do not think of the PMBOK as some dry, boring textbook. You have to see it for what it is, your complete system architecture document. It's the high-level schematic that guarantees every subsystem integrates perfectly, so that the final product actually hits its design goals. It is literally the foundation for everything else we're about to talk about.
So if we zoom in on this blueprint, what do we actually see? It's really broken down into three core components. You've got the project lifecycle, which is kind of the overall sequence of phases. Then you have the 5 process groups, which act like the system's operational modes. And finally, the 9 knowledge areas. Now these are cool. Think of them as the specialized functional blocks on our circuit board. For today, we're going to dig into those last 2.
All right, let's flip the main switch and power this system on. We're going to start with those 5 process groups. The best way to think of them is as the operational signal flow, the exact sequence that takes our project from a cold, dead start all the way to a successful power down and delivery.
And what's awesome is how intuitive this whole flow is for an engineer. First, you initiate. You're basically just applying power. Then you plan. This is like loading the firmware, the operational code that tells the system what its mission is. Next, you execute. You run the main program. And while all that's happening, you are constantly monitoring and controlling, running diagnostics, checking signals, basically a continuous feedback loop. And finally, you close the project down with an orderly shutdown, delivering the final validated output. See? It just makes sense.
So if the process groups are the operational flow, what's actually doing all the work? That is where the knowledge areas come into play. I want you to picture your project as a complex integrated circuit. Well, the knowledge areas are all the specialized, functional modules designed right onto that chip.
Seriously, this is the perfect way to visualize it. Each one of these 9 modules, from scope to cost to risk management, it has a very specific job to do. They're all interconnected, probably through a main data bus, and they absolutely have to work in perfect sync for the whole system to function correctly. So let's put a few of the most critical ones under the microscope. First up, scope management. Think of this as the module that writes the system's datasheet. It defines every single parameter, every I/O pen, every performance characteristic. Its main job is to lock those specifications down and prevent signal noise, things like feature creep that can totally corrupt the output and throw the whole project off the rails. Next, time management. And this one's easy, right? Every digital system needs a clock. And that is exactly what this is. This module is the master oscillator, generating the clock signal for the entire project. It sequences every single task, making sure all operations happen in the correct order with precise timing, so you don't get nasty stuff like race conditions or data corruption. And of course, you can't run any system without power. That brings us to cost management. This is your system's power management unit, or PMU. Its entire job is to allocate the project's energy, which is the budget, to all those different functional blocks. It constantly monitors power consumption to make sure the system doesn't draw too much current and cause a catastrophic failure, by running out of resources. Okay, so now that we've seen a few of these key modules, we have to talk about how they all interact. Because as you know, in any real system, you can't just tweak one parameter without affecting everything else.
This brings us right to the core challenge of project management, balancing the fundamental constraints of the system. This is usually called the triple constraints, but for our purposes, let's call it the power triangle. It just fits better. The three vertices are those key modules we just talked about: scope, time, and cost. And what's right in the middle, totally determined by the balance of those 3 points? Quality, the overall quality of your output. And you simply cannot change one vertex without affecting the others.
You have to think of this relationship as a fundamental law of physics for projects. It's like Ohm's law. It's not a suggestion, it's just how reality works. If you increase the scope, the complexity of the circuit, you will have to increase the time or the cost. Pushing on one point of this triangle will always distort the others, and that has a direct impact on the quality of your final output. It is a non-negotiable trade-off. So who's the one responsible for managing this delicate balance? Well, that's the project manager, or as we should probably call them, the lead systems engineer. And to do this job right, they need way more than just the blueprint. They need a very specific toolkit full of expertise. This role really comes down to 5 key areas of expertise. Obviously, you have to know that PMBOK blueprint inside and out. You also need deep application knowledge. I mean, you can't manage a chip design if you don't understand semiconductor physics, right? You also have to get the project environment, have general management skills, and, this one's huge, you need excellent interpersonal skills. That's the human interface, and we all know that can be the most complex and difficult component to debug.
And that really brings us to the key idea of this whole explainer. The most innovative, the most robust, the most successful products, the systems that truly change the game, they don't just happen by luck or by accident. They are always the result of a rigorous, disciplined process. Great systems are managed by design.
So, as you head back to your desk, I'll just leave you with this one question to think about. When you kick off your next complex build, are you just plugging things in and hoping for the best? Or is your blueprint, your master plan, truly and intentionally designed for success? Thanks for joining me.